Okay, all right. Are you able to hear me now? I hope I am audible now. I was just doing a mic test. If you're able to hear me clearly, please select yes. Also, if you have any generic questions related to GMAT Quant, hold back on them. We will always have a Q&A session at the end of the session. Hold on to them. Of course, use the chat box during the session to ask any questions related to whatever we are discussing on that particular question or that particular topic. Don't feel shy. Feel free to type anything in the chat box that you think can contribute towards the session. All right, I think there's no problem in the audio. I think most of you are able to hear it. If a few of you are not able to hear my voice, it could be because of your connection. Please check your connection and reset it if there's a problem. All right. Let me run another poll to just see if you're able to see my screen. These are two things that I want to kind of make sure are in the right place before we start. Are you able to see the screen? I've just shared my screen. If you're able to see the screen which says Art of Picking Numbers, I think everything is in place. Okay, all right. Feel free. We'll start in about a minute or two. So if just a few of you are not able to see my screen, as I said, just check your connection and make sure that your connection is in place. If there is some kind of buffering, just reset your router or move to a better place if you're using a 4G connection. All right, I see a question in the chat box. The duration of this webinar will be around 90 to 100 minutes, which means I intend to wrap up this webinar by 8:30 or at the most 8:40, right? 8:40 or 8:45. All right, I hope that answers your question. All right, so most of you are able to see my screen. There are a few of you who might want to reset your connections and rejoin back. All right. So as you've already understood from the introduction slide, this webinar, and most of you already know that the topic of this webinar is how to learn the art of picking numbers. And rightly so, I think we've used the right word. We've not called it a science because it's not an exact science. There is no rule book, okay, which you can refer to understand how to pick numbers. It's more an art that you have to develop during your preparation for the GMAT. And because it's an art, it's obvious that it can be perfected, or you can at least come close to perfection by practicing it continuously whenever you solve questions. I may also use the word consciously because picking numbers is something that a lot of students look down upon. I should say, from my experience, I have come across a lot of students who feel that it is not smart, a smart strategy to pick numbers, right? I've come across students who look down upon it. They almost look at it with a condescending kind of view. Like, this guy is picking numbers. I think he doesn't know math. In fact, I think it is actually a smart idea to learn how to pick numbers because of many reasons, right? And that's the reason why this webinar is happening, because as a GMAT prep company also we feel that this is an important important part of your preparation that can help you get better in terms of your GMAT quant skills. This is definitely one skill that you need to have in your quiver, I should say, right? One good arrow to have in your quiver is learning how to pick the right kind of numbers. All right, so My name is Arvind. I'll be taking you all through this webinar. If some of you were in my previous webinar a couple of weeks ago, you may have you may have some kind of a background of how I solve questions. I'm a senior SME at GMAT I teach quant. I take up live sessions, webinars, and I do personal tutoring. I have around 12 plus years of edtech experience, having taught GRE, GMAT, CAT, and some of the other entrance exams. I've taken the different exams myself, and these are my scores. So, without wasting any more time with this brief background about myself, I think we can get to the next part of this webinar. We have the main part, which according to me should last about 80 to 90 minutes. So we'll be wrapping up solving the question part by around 8:30, 8:20, 8:30, and I'll devote about 5 to 10 minutes for the Q&A in case any of you have questions. So you already know what you learned today, but I would like to quickly make a few points of what is going to come and why it is important that you stay back till the end of this webinar. Okay. So most of you will ask me this question first, because this is probably the first question that you have in your mind, even as you enter this webinar. So a lot of you are thinking, okay, when do I pick numbers? I'll come to that a little later. But even before you start asking when do I pick numbers, I think it's important for you to ask another question. And that other question, according to me, is why should you pick numbers, right? Because I feel once the why is taken care of, I think you'll be able to take care of the when and when not in a more logical way. So why should you pick numbers? I think it's an important strategy, as I mentioned already, that you learn how to pick numbers. Why? One reason I can give, and all of you will agree, is it makes your calculation easier, right? Let us agree that most of us are comfortable in dealing with numbers than variables, right? We can add numbers faster, we can multiply, factor out numbers, divide, right? Find the squares, square roots much faster when it comes to numbers than when we have variables, right? Second, because the calculations are easier, right, we have less scope for errors. Okay. I'm of the unequivocal opinion that the traditional approach of solving math that we learned in school, right, where we take variables, create equations, expressions, try to solve them, and find the value of the variable, I think it has a high propensity for introducing errors, calculation errors, silly mistakes, right? Whereas I believe that when you take numbers, you have less scope for errors. You're less likely to make an error. That's point number one. Point number two is, even if you make an error, I think fault finding is much easier than when you use numbers, right? And last but definitely not the least, it's a rewarding process. What do I mean rewarding process? There are two aspects. One, it's rewarding intellectually. You end up having that sense of satisfaction that, okay, this was fairly quick. This method was fairly quick. I didn't know I could solve this problem in such, less amount of time or so easily. Second, it is rewarding in terms of the test itself. What do I mean by this? GMAT actually rewards you when you come up with such smart strategies. One of the strategies is obviously picking numbers. Okay. So GMAT is not hell-bent on testing your math skills. Okay. Let's remember that GMAT is not a math Olympiad. Okay. And you're not being tested on whether you can solve an equation the traditional way or not. Okay, nobody is asking you to solve a quadratic equation the way it has to be solved. All right, if there are 5 options given, you can very well plug in the number from the options and see which number satisfies the quadratic equation, which unfortunately a lot of us don't do, right? Because we feel it may put us into trouble. In fact, on the contrary, it may pull you out of trouble, according to me, right? So, therefore, the fourth point is very important for you to remember, that picking numbers can be rewarding. I don't think, especially on the GMAT. Therefore, I don't think you have a bigger why than this. This is, according to me, the biggest reason why you should start, learning how to pick numbers. Okay. So these are like 3 or 4 reasons that I have at the top of my mind. If somebody comes and asks me, why should I solve a question using numbers? Okay. Now, the very next question comes up, when do I pick a number? Unfortunately, as I said, there is no rule book. If there was a rule book, I would call this webinar as the science of picking numbers, right? But unfortunately, there is no rule book. It's an art. All right. So when do I pick numbers? There are certain points that you can keep in mind as maybe triggers, which can probably help you figure out, okay, here's a problem where I could try numbers rather than trying my usual approach of solving questions. Okay. First point is very obvious. If your traditional approach looks lengthier, it looks too cumbersome, okay, or you're just not able to figure out what to do, how do I frame an equation, how do I develop variables, what equation will I get, how do I solve this equation? If you have come to a point, or if you have come to a dead end in terms of solving the problem using the traditional approach, you might want to consider taking numbers. Okay, that's one trigger. A very good trigger to have is if you have variables in the answer options. Okay, if you have variables in the answer options, I'm talking of problem solving questions where you see the options in terms of either a x or a y or a m or a p or a q. Okay, that's a very good trigger for you to think of plugging numbers, plugging simple numbers that satisfy the constraint given in the question statement. Next, very often must be, could be questions, which are the special type of problem solving questions, require you to test cases. So that's another obvious trigger for you to say, okay, here I can try numbers. Okay, data sufficiency, especially testing out the individual statements, right? You have to try numbers in a lot of cases. Apart from this, if you look at it from the topic perspective, I feel topics like numbers, okay, um, topics like ratios and percents. In fact, when I say numbers, I can also probably talk of a topic like questions on fractions and decimals. Topics like time and work. Okay, to some extent, a topic like equations, algebra. Okay, some extent, a topic like inequalities, some questions, right, are topics where you should pick numbers based on the constraints given. So this is when to pick numbers. So the flip side then comes up, when not to pick numbers. Okay, I would like to address that as well. When not to pick numbers, I would say maybe when you come across topics like geometry, where you cannot just pick a number and solve it. It depends on the diagram, it depends on your knowledge of a property, how you apply that property becomes important. So I don't think number plugging works really well in a topic like geometry. Maybe a topic like PNC, probability, again, here number plugging doesn't really work well all the time. Okay. Um, in a lot of questions, I remember that I mentioned inequalities here, but unfortunately, inequalities also features in the when not. Okay. So that is something you need to figure out. There is a dichotomy. You need to practice enough questions to figure out, okay, what are the types of inequalities questions where I can plug in numbers, and what are the type of inequalities. Typically, when it comes to inequalities questions where you have to combine the inequalities, okay, plugging numbers can be dangerous. Okay, so that's that. I hope that has given you an idea of what is going to come from here on. All right, I hope I've given you a sort of a roadmap as to when you can plug in and when you should not. And because today's webinar is on plugging in numbers, obviously the questions that I've picked will push you all towards plugging in numbers. All right. And by the end of whatever 6 or 7 questions we are solving, you'll have a clear idea of what kind of numbers to pick, when to pick such numbers, and when not to pick a certain set of numbers. Right. So if there are any questions at this stage related to what we discussed till now, I'd like to quickly take 1 or 2 minutes before we start with the questions. If we are all good, we can actually start with the questions. All right. So, yeah, if there are any quick questions that you think can add to the discussion, please go ahead. Otherwise, we can start with the questions. Okay, let me make it a point that on every question that we have today, I'll give you 3 minutes, right? I'll have a 3-minute timer running on my mobile phone. So from start to end, I'll give you 3 minutes. The poll will close at 3 minutes. And after that, we'll start the discussion on every question that we take up. All right. There are a few examples that I will solve on my own to just demonstrate how you could pick numbers in certain scenarios, right? So in such questions, you could probably solve with me, right? But do not post your answers in the chat box. Okay. So I'm reiterating that in worked examples that I'm solving on the screen, please do not post your answers in the chat box. And in general, refrain from posting your answers in the chat box. Use the poll. Picking numbers in pieces of the puzzle question. Harsimran, I don't understand the pieces of the puzzle question is not a frequent occurrence, right? And regarding probability, I've already mentioned that it's probably not a good idea. When it comes to set theory or Venn diagrams, it depends. It depends on the type of question. So I cannot generalize there. Okay. So there could be questions in set theory where you could plug in numbers. There are other questions where plugging in numbers could be, may not be a good idea. So that's something I cannot generalize. Okay. All right. I think we are good to go in terms of the first question. I think these are 4 scenarios that I've taken up in terms of when to pick numbers. I've already given you a broad overview of when to pick numbers in terms of the topics and in terms of the model of questions. So we'll go and discuss some of these models, some of these question types one by one in terms of scenarios. So the first scenario that I've picked here is a scenario where you have to pick numbers in questions which are concept based. All right. This is typically questions where you have questions from numbers or maybe time and work or sometimes even time and distance. Okay. Fractions. Topics like these. Okay. Word problems, I've taken it under scenario 2. Questions on inequalities and algebra I've taken as scenario 3. And the fourth scenario is an interesting scenario. You will understand what to do in that scenario when we come there. All right. So without wasting any more time, I will start with the first scenario. A scenario where you have to select numbers based on the concept tested in the question. All right. That's the first scenario. for which I want all of you to solve this question. I'll give you all 3 minutes starting now. All right, your timer started. I'm running a poll now. Once you're done, you can mark your answers on the poll. Okay, guys, that is 3 minutes. If you haven't marked your answer yet, you should start marking your answers now. Probably hold on for another 15 seconds before I close the poll. All right, I see a good trend in terms of the percentages. Okay, that's time. End of poll. Okay, this is nice. Okay, 45% of you say A for alpha, 10% each for B for beta and C for Charlie, 30% for D for delta. All right, I have a few people marking E. All right, so this is a beautiful question to start with, according to me, because it has two components that I talked of. One component is it's a must be true question. Second, it is based on a very simple concept that you're dealing with prime numbers. Now, why did I put this question here? Because it's saying that it is concept based. If you're wondering what concept you can use here, unfortunately, there are not too many concepts related to prime numbers, right? Um, the only concept that you can think of is that okay, you can have even primes and odd primes. That's one concept you can think of, which is eventually related to odds and evens, right? That is one. Another concept that most people will end up probably using is that a prime number greater than 3 can be written as 6k plus 1, 6k minus 1. Although, if I had to use this concept, I would be at a loss as to how I would actually use it. In fact, if I started using this concept in terms of simplifying these expressions, I think I would be putting myself into more trouble, right? That is exactly what I wanted to convey in this question, that the best approach to solving this question is to understand that if p is a prime number, p can be 2, 3, 5, 7, 11, and so on. Okay. Therefore, the best way to solve this question is by picking a few of these values and trying to figure out which of the statement here must be true. Okay, that's another thing I wanted to say. In a must be true question, most students try to prove the statement true. In fact, you should try to prove the opposite, right? You should try to prove the statements false. How many times? Once. This is the strategy that you have to follow in a must be true question. Because if you can prove a statement false once, you have proved that it is not always true. Okay. Remember, when you say which statement must be true, you're trying to find out which statement is always true. So therefore, if you prove that a statement is false exactly once, you automatically proven that it is not always true. Okay. If you're not able to prove a statement false, what happens if you're not able to do this? If you're not able to do this, it automatically means that the statement is always true. Okay, that's the strategy for a must be question. So I take p equal to 2, which is the easiest value I can take for p. So p square minus p. All right, if I take p equal to 2, p square would be 4. So p square minus p, 4 minus 2 is divisible by 2. Absolutely. 4 minus 2 is absolutely divisible by 2. Right? So this is true. So do I stop here? No. Because it's a must be true question, I should try a few more cases. I could probably take p equal to 3. P square would be 9. Okay. P square minus p here would be 6. 6 is definitely divisible by 2, so I got another tick mark. P equal to 5, p square equal to 25, p square minus p would be 20. So I got another tick mark because 20 is divisible by 2. By now, I figured out that p square minus p is probably always divisible by 2 because I'm not able to prove it false. What is the mathematical backing to this? If you observe p square minus p, there's a p common. You can write this as p times p minus 1. And p times p minus 1 is the product of two consecutive integers. And mathematically, the product of two consecutive integers is always even. And any number that is always even is divisible by 2, which means you cannot prove the first statement false at all. Therefore, the first statement has to be true. Okay? So the first statement has to be a part of your answer. Okay? Which means 2 only is not your answer, 3 only is not your answer. Okay? So anyone who marked Bravo and Charlie are in for a disappointment already. Next. So we've already proved the first statement to be true. It cannot be false. If you look at the options, you can also rule out option E, because you've already proved that the first statement is always true. So you cannot say none of them is always true. Okay? Which means you're left with two options, option A and option D. Now, if you look at option D, the second statement is the only statement you have to test, right? So let us test the statement 2 using the same values. So p square minus 1. So let's say p equal to 2. What happens to the expression? 4 minus 1 into 2 plus 1, 3. 4 minus 1 is 3. Sorry, 2 plus 3 is 5. My bad. 2 plus 3 is 5. 3 times 5 is 15. Is 15 divisible by 6? Not really. So by taking p equal to 2, I've proved that this statement is not always true. So can I include it as a part of my answer? I can't. Did I have to check for the third statement? I didn't have to. I can straight away mark A for alpha as my answer and move ahead. However, when you're practicing GMAT Quant, you cannot do this. Whatever I did now has to be done on the test, right? But when you're practicing, you still have to test the third statement. So let's say I take p equal to 2. Okay. P square minus 1 is already 4 minus 1. 4 minus 1 times 4 minus 9. All right. 4 minus 1 is 3. 4 minus 9 is minus 5. 3 times minus 5 is minus 15. Minus 15 is definitely not divisible by 16, which means the third statement is also not always true. Therefore, by just picking one value for p, I was able to disprove two statements and arrive at the final answer of A for alpha. Any questions here? So in a question like this, where there's an open invitation for you to try numbers, you should not be hell-bent on taking the algebraic approach. Okay? Because it will just take you more time to get to the same answer. If I take 1 minute to get to this answer, taking the algebraic approach, you will probably take 2 or 2.5 minutes to get to the same answer. That's when you have to think, right? That's when you have to think, should I have done this? Should I be so particular about solving the question algebraically? My answer is no, right? As long as you get the answer, plugging numbers, why do you have to be very particular about algebra? Why we need to test the third statement? Anupam, I said that in an exam situation, you don't have to test the third statement. But when you are practicing questions at home, you still have to know how to deal with the third statement. Okay? That's why I have to show you how to deal with it. Okay? I hope that answers your question. All right, guys. Any other questions on this? Yeah. Any other questions on question number 1? Can we solve second by taking 3 as the number? Ashish, just answer one question. Have I proved the second statement false by taking 2? Was I able to prove the second statement false by taking the value of p as 2? Ashish. Exactly. Good answer, Azizul. Exactly. Yes, there is no need to test the third one. Ashish, your answer is yes. So my point is, if I was able to prove that the second statement is false by taking p equal to 2, can you tell me why should I take p equal to 3? Is it needed? So you will understand that it is not needed. Can we solve the second one by taking 3 as the number? Yes, you can. Right? You can. But what does it prove? It proves the statement to be true. And that is where the problem lies. So look at the language you are using. It can be true. I did not ask you a can be true question. I asked you a must be true question. So please learn to differentiate between the two. I did not ask you which of the following could be true. Right? I'm asking you a question on certainty. I want you to be certain that it is always divisible by 6. Okay, hope that answers your question and hope that clarifies your doubt. Any other questions, people? All right, let's go on to the next question then. Okay, so this was question number 1. I did not need the solution slide. I had enough space. All right. So, just to let you know that we, whatever we propose on the webinars is whatever we do on our course as well. Okay. So you can see from the screen grab that in questions where we know that there is a constraint that we can take advantage of, you see that we have taken values in terms of analyzing the stem here, right? This is where we have taken values. So it's not like we propose something but we don't follow it ourselves, right? We practice what we preach, even in our course. Wherever we feel taking values is a better approach to solving the question, a faster one, we do that, right? Okay. So when it comes to topics like prime numbers, composite numbers, questions on probably finding divisibility, remainders, right? Questions related to fractions. These are topics where you can pick numbers based on the constraints given. All right. Any questions? Okay, Azizul, you have a personal question for me. Okay. All right. Okay, Azizul, hang on to that question. It's a generic question. Hang on to it. Okay, I'll come back to that question at the end of this webinar. Okay. All right, people. Let's go to the next question. Question number 2. As always, I'll give you 3 minutes. Solve this. Starting now. Let me run the poll. Here we go. Okay, people, that is time. That's 3 minutes. A lot of you have marked their answers. Okay, that's good. Few of you have fallen for the traps. I'll hold on for another 10 seconds and then close the poll. Okay, that's the end of poll. I'm so happy that a lot of you have got the answers right. 66% of you say D for Delta, which is indeed, I think, the right answer. 16% E for Echo. I think you missed out on one important piece of information in the question and therefore fell for the trap set up for you well. Okay, I see a question. What will be the level of this type of question? This is probably a 600 to 650 level question. Definitely not a 700 plus level question. Okay. So the reason why I included this question here is because in my experience as in my experience of having taught this topic, time and work, the most common mistake that students make on this is to take a very traditional approach. Okay. We take work equal to 1 unit. Okay. And we say, okay, Ben takes 60 days, which means his rate of working. I've seen people writing so much, and I don't understand why they write so much. Right? Rate of Ben is 1/60 per day. Right? If you took this approach, it is very likely that you took a lot of time on this question. Okay? So let me do a quick poll. What do you think should be the time taken to get to the answer in this question? Okay? What do you think? Give me a range. Don't give me a number. What do you think should be the time taken to solve this question from start to end? Okay, let me see a few numbers, a few ranges in the chat box. Yes, please. Anyone saying 3 minutes, 3.5, 4? Or anyone saying 1, 30 seconds? These are all unrealistic values. In my opinion, if you take anything more than 2.5 minutes on this, okay, you have taken a very bad approach of using fractions. Okay. Nobody has told you that the work has to be 1 unit. It is just one method that you probably learned in school to solve questions related to time and work. Okay. And at that point in time, this method of using fractions probably was ideal for you to learn because you were still learning the tricks of the trade. At this stage, you're not learning the tricks of the trade. You're not learning time and work newly. You've already done it. Therefore, you have to, step up your game and look at a faster approach and stop taking the work as 1 unit. I'll tell you why, right? And when I ask this question, a lot of people who take this approach are completely stumped. Okay. So this is what they do. And what happens if Ben and Peter work together? How will I find the rate? What should I have to do? Tell me. If I have to find the combined rate of Ben and Peter, what should I do? What is the next step? Obviously, I have to add 1/60 and 1/40. Great. How do I add 1/60 and 1/40? Because they are fractions with different denominators. Right? 60 plus 40, Anupam, really? Really, you want to do that? Or was that just okay? So you take the LCM, right? So if you want to add 1/60 and 1/40, you will take the LCM of 60 and 40. That is exactly the question I asked them. If you are taking LCM at this stage, why not take LCM at this stage? Okay, and then there is no answer. Okay, because it strikes them as very logical. I know this is very logical. Whatever I'm saying now, I know it is based on sound logic. Okay? If you are taking LCM at a later stage, why not take LCM at an earlier stage? Think about it. What is wrong with it? Right? So, what we recommend is we recommend making a simple table. Ben, Peter, Ben and Peter. Okay? Time taken, rate. Unfortunately, work is not given. We have to assume the work. Ben takes 60 days. Peter takes 20 days less than Ben. So Peter takes 40 days. We already know that we would take the LCM of 60 and 40 somewhere. So let us take it now. So let us assume that work is 120 units. So what are we saying now? We are saying Ben can do 120 units in 60 days, which means he works at the rate of 2 units per day. Similarly, Peter can do the same work in 40 days. Therefore, he works at the rate of 3 units per day. Okay? If they work together, what is their combined rate? It's very easy for any of you to say now that their combined rate is 5 units per day. Okay? But do they work together at their original rate? Unfortunately not. Alright? Now let us get to the question. How many days would it take for Peter and Ben together to complete a piece of work that is 3 by 2 times of the original work? So now what is the new work they have to complete? The new work they have to complete is 3 by 2 times of 120. See how easy it is now? The new work to be done is 180 units. Okay. Who does the work? Ben and Peter together. Okay. Which means their rate will be 5 units or somewhere close to 5 units. What happens here? Ben works at 50% of his original efficiency. Okay. So what will be the efficiency of Ben now? Because he is ill, he only does 1 unit per day. Whereas Peter is still doing 3 units per day. So how many units will they complete in one day? They will complete 4 units in one day. Okay. So what will be the time taken to complete 180 units? So time equal to work by rate. So that's obviously 180 by 4. 180 by 4 is 45. Alright. So in a topic like time and work, assuming a number for the work makes your life a lot simpler. Alright. And what is that number that you have to consider? The number that you have to consider is the LCM of the times given. Okay. Why do I say LCM of the times? Because you would have seen in a lot of time and work questions, it is always the time that is given. The work is always assumed. Okay. And the rate is always calculated. All right. So I hope this is clear to all of you. So this is a technique that I've heard students telling me has changed the way they look at time and work questions, right? So please start using this technique whenever you solve time and work questions. 90% of the time and work questions can be solved if you know how to find the LCM of numbers. Any questions on this? So as I said, taking numbers actually makes a life a lot simpler. And by now, I see a lot of you agreeing with what I say. Therefore, we'll go to the next scenario here where we discuss the next model of questions where we can plug in numbers. Word problems. As you all know, word problems are replete with variables. Okay, they are very nice stories. Sometimes they are mini RCs with so much information that they end up overwhelming you. Right? They give you so many variables. Using those variables, you have to create equations or expressions and solve them. which may not be the ideal scenario, ideal approach in all questions, right? So therefore, what I've done here is I'll take an example of how I would solve a question, a word problem, let's say related to ratios or percentages, right? Without having to take variables. Okay, of course, I can take variables and solve it, but the moment I see percentages, I either think of 100 or its multiples. Okay, here in this question, all of you can solve along with me. There is no poll for this. Okay, you can solve along with me and verify if you are headed in the right direction. All right, 60% of the members of a special task force. So, members, because I see a percentage, let me take the number of members as 100. Okay, so I know 60% of this 100, which is 60, are officers, while the rest are cadets. So obviously the remaining 40 are cadets. 65% of the task force members are men. Okay, I'll probably write it here like this. So out of 100, 65 are men. Therefore, the remaining 35 are women. Okay. Now, if 30% of the officers, remember, this is now your 100%. Okay. This is your 100% now. Because you're saying 30% of the officers are women. So, how many women? 18 women. Therefore, how many men? 42 men. Okay. We know that there are a total of 65 men, out of which 42 are officers. All right. Which means 23 are male cadets. And therefore, I think 17 are female cadets. Okay. So just by taking 100, you have simplified the question in like 30 to 40 seconds. Okay. It hardly took you more than that time. Now, all that you're left with is to answer the question. What percentage of the cadets? Okay. What percentage of 40? Okay. So that's your whole. So you're asking what percentage of 40 are men? Okay. So that's 23. What percentage of cadets are men? So I think I made a mistake here in terms of the options given. I probably wanted to say what percentage of men are cadets. All right. Anyways, I hope you will ignore this mistake on my part and understand that, okay, ignore the options for a while, but taken the approach, I probably did not change the options. Probably that's a mistake on my part. All right. All right. So this comes up with about, I think, 115 by 2. That's about 57.5%. Okay. How did you get the breakup of 40 cadets? Anupam, you have to understand there are 100 members, out of which the question says 60% are officers, while the rest are cadets. So if 60% are officers, the remaining 40% are cadets, right? All right, guys. So you'll have to pardon me on this slight oversight that I had in terms of not changing the options. I probably had a different question in mind, didn't change the options, but I hope like the approach is clear. When it comes to questions on percentages and ratios, especially percentages, the numbers that you can assume are either multiples of 100 or multiples of 100. Okay. 100 may not work all the time. Anupam, you have to understand that there are 65 men in total, out of which 42 men are officers, right? So the remaining 23 should be cadets, right? Similarly, if 23 are men, the remaining 17 are women, right? Is that clear now? Okay, any questions, guys? Apart from that small mistake that I made, any questions on the question itself? Please let me know. So I hope I've kind of demonstrated how to take numbers when it comes to ratios and percentages. If there are no questions, we'll go to the next question, which is actually on percentages. It's a little difficult than this, but if there are questions, I'd like to take them up quickly now. All right, people. So let's go to the actual question that I wanted to solve. I wanted you guys to solve. I'll give you 3 minutes on this. Starting now. Let me run the poll. Here we go. I start the. Yes. There we go. The poll is done. Slightly wordy question. Be careful not to miss out information. All right, people, that is 3 minutes. Please mark your answers. I see no other option being represented except 2. Let me hold on for maybe another 20 seconds. This is a fairly lengthy question. Hope you have checked your calculations correctly. Okay, so I almost ended up giving you close to 4 minutes on this. Okay. Time up, therefore. End of poll. Okay, 16% A for alpha, 33% B, 33% C, 16% E. So there's no one for D. Okay, I don't know whether that's good or not. Okay, the fight is between B and C, Bravo and Charlie. Let's see. But first impressions, what do you think? Is it a difficult question? If yes, why? What are your reasons? Why do you say it's a difficult question? Is it testing a very difficult concept? Is it difficult conceptually? If you say no, what are the other reasons why you say it is difficult? Okay, calculations. Okay, lengthy calculations. If you don't know certain aspects of percentages, I would say. Okay. All right. What are those aspects? What is that one important aspect that I'm talking of? I'm talking of the fraction equivalence of percentages. Okay. What do I mean by this? We know that 50% is represented as half. Okay. So half is the fractional equivalent of 50%. So you need to know the fractional equivalent of common percentages. Like, for example, 60% is 3 by 5. Okay. 33.33% is 1 by 3. 25% is like 1 by 4. 100% is easy. 100% is 1. And you have to understand that when you add different percentages, you can get different fractions. So, for example, 100% plus 33.33% is what is given here. Okay. So, therefore, 133.33% will be 1 plus 1 by 3, that is 4 by 3. Similarly, if you add 50% with 33.33%, you get 83.33%, which is given here. So therefore, 83.33% is 1 by 2 plus 1 by 3, that is 6 in the LCM, 2 plus 3, 5. Okay. So if you are able to use these fractions, your number plugging becomes very simple. All right. Otherwise, you will struggle in terms of creating the equations. If you can't create the right equations, then you obviously will take more time to solve it. Okay. Now that we've understood what the percentages represent, let us quickly write them here and in one corner of the screen. So I know 60% is 3 by 5. I know 133.33% is 4 by 3. I know 83.33% is 5 by 6. Let us now look at the relationships. I didn't even, as you observed, I did not even look at the first statement because it does not give me any information about numbers. Okay, so in a complex word problem, I ignore statements that do not give me any information about the numbers. All right, that's how I save time. Okay, they found that the money with Andy. Okay, let me represent that as A. For some reason, okay. A is equal to 60% of that with Barry. So 3/5 of B. All right. While the money with Cecil was 133.33% of the sum with Andy. So sum here refers to money. Right. So Cecil equal to 4 by 3 of A. The prize money won by Danny. So Danny equal to 5/6 of Cecil. All right. In terms of Danny's money, say D. So the question is already defining D as Danny's money. In terms of D, that's why all your answers are in terms of D. How much more money? So we'll stop here, right? We'll take a look at this question stem later. All right. Now tell me, what is the number that I have to assume here where do I start from? Okay. I know this is a problem on percentages, but because it's a problem on percentages, if you just assume 100, you know you're in for trouble. Okay. So all percentages problems cannot be solved by taking 100. You'll also have to pay attention to certain aspects like fractions, certain aspects like what percentages are actually given to you. I will say that my starting point is probably taking a number which can be divided by 5, 3, and 6. Okay? Which is the LCM of 3, 5, and 6 is 30. Okay? But because I have a percentage, I will just add a 0 to it, and I'll probably take 300. If you want a slightly bigger number, you could probably take 600. I'm okay with either of them. A says I did 300, no problem. I will just take a bigger number. I take bigger numbers because they help me avoid fractions and decimals. I do not like getting into decimals, so I'll probably take 600. Which value should I take as 600? Tell me. What value should I take as 600? Or if you're okay with 300, I'm okay with 300. Okay. So let me take B. B as 300 because A depends on B. Okay. C depends on A and D depends on C. So understand the dependency. A depends on B, C depends on A, and D depends on C. So it makes sense for us to start with B. Okay. All right. B equal to 300, which means A will be 3/5 of 300, which is 180. C will be 4/3 of A, which is 4/3 of 180. 3 ones are 3 6 are 60. So that's 240. And D, Danny will be 5/6 of Cecil. So 5/6 of 240. Okay. That is 40, that is 200. Okay. So the question is, we can simplify the numbers. Andy has 180, Barry has 300, Cecil has 240, and Danny has 200. Okay. Yes. So all of you who took numbers probably found this question easy. Beyond this stage, what is the question? How much more money should Andy have won? Okay, so that he could equal Cecil in terms of prize money won. You want to find out how much more money should Andy win to become equal to Cecil. You tell me how much more money should he win. You can post your answers in the chat box. How much more money should he win? $60, $30, $40, what is it? Clearly, the difference between 240 and 180 is 60. So he has, let's say we have taken everything in dollars. So he has to win $60. Okay. My question is, this 60 is what fraction in terms of D? So I'm asking you, 60 is how much of D? What is D? So if I rephrase this question, 60 is how much of 200? Okay. You know that 60 is 30% of 200. Which means he must have won this much extra so that he could become equal to Cecil. Am I clear on that? Any questions for me? Okay, all right, people. So that's that. Okay, so that I think clarifies one thing, that if you look at a question on percentages, just don't blindly take 100. Okay, especially if you see percentages like 133.33, 83.33. Learn your fractions. Learning your fractions will help you understand that your denominator should also be considered. Okay, it is important to take a number that is divisible by the number in the denominator, not just any number that is 100, because remember, 100 is not divisible by 3 or 6 or 7 or any of these numbers. Sanket, you can solve it in terms of fractional terms only. Okay, you can definitely do it because there is a relationship between all the variables. You can set up the relationship and solve it. You'll get the same answer, but it will probably end up taking a little more time than this approach, and it will be a little more mentally taxing for you because you have to invest that kind of a mental bandwidth. Okay, guys, any problem? Any other questions here? All right. Therefore, let's go to the next question now. Question number 4. Let me start a timer for you guys. 3 minutes starting now. Running the poll. Here you go. There's your poll. Okay, guys, that's 3 minutes. I'll hold on for another 20 seconds before I close the poll. Okay, that's an interesting fight I have in front of me between two options. Okay, and that's the end of poll. I think in the end, the winner won by a very small margin. I had 50% of you marking A and 50% of you marking B. At the end, I think it slightly went in favor of B. 54% B for Bravo, 45% A for Alpha. Okay. So here's a question again which tests your knowledge of percentages, right? But it also tests your knowledge of one more concept, that is the concept of compound interest. Okay. If you observe here, you see that the value of a car reduces such a way that the value at the end of the year is 16.6% lesser than the value at the start of the year. Okay, which means whatever your value is at the start, that is the principal, it is getting reduced by whatever percentage, and you get a new number at the start of the next year, which reduces again by the same percentage at the end of the next year, and so on. Okay, so there's actually a question on compound interest. At least it's based on that philosophy. So therefore, one way of solving this is obviously by taking the amount formula. Amount is principal into 1. Instead of 1 plus, you would take 1 minus r by 100 to the power of t and solve it. But I'm sure a lot of you do not want to do that because of two reasons. One, the percentage is not easy. Second, you have the exponent to be almost 4 years because you're looking at 2018 and 14. I don't know how many of you want to take up the challenge of putting a 4 here, right? Here and simplifying. I certainly don't want to do that. So, if I want to solve this problem, I'll use my knowledge of percentages. What is the knowledge I'll use? Value at the end of an year. Value at the end of year equal to 16.66% less. 16.66% is 1 by 6. Okay. So I'm saying it becomes lesser by this much, which means it should be 5 by 6 at the value of the value at the start of the year. Okay. So value at the end of any year is 5/6 of the value at the start of the year. If you plug in 16.66 in the place of r, you will still get the same 5 by 6. Okay. But you'll get 5 by 6 to the power of 4, which I don't want to get into. Okay. So that's why I'm taking the easy approach. That's one point. Second point is, I want the value of the car at the end of 2014. This is start of 2018. So what I'll do is I'll make a simple table. Okay. Start, end. I'll just put in the years 2014, 2015, 2016, 2017, and 2018. Now, I want the value of the car at the end of 2014. Remember, whatever the value of the car at the end of 2014 will be the same value at the start of 2015. So this will be the same value. This will be the same value, and so on. I know the value of the car at the start of 2018 was 6,250. Okay. Now, I know that the value is reducing by 1/6. So now, instead of using a random number, I'll use the numbers in the options. What is the clue I have? The clue I have is my number should be divisible by 6. Okay. Now, clearly, 256 is not divisible by 6. So I will hold on to E. All right. Second point is, you are reducing the value. You cannot reduce 2,560 and make it become 6,250. That's impossible. Okay, so I straight away roll out E for echo. Second, 7,250. I know 7,250, 7 plus 2, 9, 9 plus 5, 14 is not divisible by 3. So this is not divisible by 6. Okay, so I'll hold on to this, or at least I will be doubtful of this. Okay, I may not eliminate it fully, but I'm doubtful. The remaining numbers are divisible by 6. So what will I do? I'll pick the easiest number for me to check. And what will I do? I'll plug it in here. 12,960 at the end of 2014. So 12,960 at the start of 2015. So what should I get? I should get 12,960 into 5 by 6 will give me this value, into 5 by 6 will give me this value, into 5 by 6 will give me this value. Whatever value I get here will be the same value here. Okay. So let us see if I get 6,250 here. You've already realized that 625 is 5 to the power of 4. If you've already realized this, you're already in a good position. Okay. So 6 into 6, 36. 36 into 6, 216. Okay. Let's divide this by 6. 6 2s are 12. 6 1s are 6, 36. 6 6 are 36. Okay. Now I'll divide this by the other 6. 36. I'll divide this by the other 6. 60. Now clearly 60 times 125 is not going to give me 6,250. What will it give me? Let us see. 125 times 0 is 120, 0. 125 times 6 is 900. It will give me 9,000. Okay, I'll get 9,000 here. I don't want 9,000. I want 6,250. That is where a lot of you fell for the trap. You did not realize that the value at the end of 2014 is the same as the value at the start of 2015. Okay. So therefore, 12,960 is not my answer. What is the next value I will try? I will obviously try the next bigger value. That is 10,800. Okay. So 10,800. Now, by now, all of you have realized that 10,800 multiplied by 5 by 6, multiplied by 5 by 6, multiplied by 5 by 6 will eventually give you whatever number you require. So I think in terms of the poll, a lot of you fell for the trap answer because you did not realize that the value at the end of 2014 is the same as the value at the start of 2015. That's why a lot of you fell for 45%. For A. That's one point. Second point I want to make is sometimes you need to utilize your answer options to pick numbers. You cannot pick random numbers. Okay. Utilize your answer options to pick numbers because they are readily available to you. All right. So in this case, obviously, there were some answer options which were absolute nonsense. 2,560 was nonsense. By now you understand that 7,250 is also not going to make the cut because it's very close to 6,250. Similarly, 9,000 also will not make the cut. So obvious answer here by eliminating also is 10,800. On an ending note, I would say do not try to calculate fully. If you have eliminated 4 options, 10,800 has to be your answer. Okay. So that's one more type of number picking from the options. Any questions at this stage? I think I've taken a little more time than I had planned. We are at 8:27. So without wasting any more time, I'll quickly move on to the next scenario where we take up questions on algebra. Okay, where we solve some questions related to algebraic concepts. The first question is on inequalities. I want you to go ahead and solve this question. I'll give you 3 minutes starting now. This is a very good question, a DS question on inequalities. Let me run the poll now. Let me reset the poll and run it again. Go ahead, guys. People, that is 3 minutes. I see that a lot of you have already marked your answers, so probably I'll close the poll in another 10 seconds and we discuss, because we're also running out of time. Okay, so that's the end of poll. 42% B for Bravo. Okay, B for Bravo seemed to be, for some reason, the favorite option right from the start. I don't know why, right? Um, A for Alpha, 5%, 15% C for Charlie, D for Delta is 10%, 26% E for Echo. Okay, let us see what the question has to say. Is there some information given in the question that can help us? And how do we combine it with the statements? Okay. And because we are discussing how to pick numbers, I will take the approach of plugging numbers only. All right. And when it comes to plugging numbers for algebra kind of questions, we recommend that you use the number line. Okay. On the number line, we identify 4 intervals. These 4 intervals cover all the values that you want to cover. And don't forget, there is a 0, there is a 1, there is a -1. Sometimes you may have to take these values themselves. Okay. So in questions like these, taking the number line approach actually simplifies your solution a lot. How do we do it? Okay. Now, first things first, I know x is more than y. Okay, so I know x is on the right side of y. Question is y square more than x square? I'll not take an algebraic approach here for obvious reasons because we are learning how to pick numbers. Okay, so what are the answers you can get here? Is y square more than x square? Okay, that's the question. This is a yes no type of DS question. So what's a yes? The yes would be yes, y square is more than x square. The no would be no, y square is less than or equal to x square. Remember, a no is automatically an accepted answer. Don't go around looking for a yes. Don't go around trying to prove that y square is more than x square. Okay, that's one point I have to make. Now, there's nothing else given in the question. I only know x is more than y. I don't know whether they are positive, negative, where they are. So I'll move on to the first statement. Okay. First statement says x is more than 0. How do I deal with this? So I know x is on the right side of 0. Do I know where it is? I don't know. So can it be in between 0 to 1? It can be. Can it be in between 1 to infinity? It can be. So let us take a few values. I don't know where y is, by the way, right? The only thing I know is x is more than y. So if x is more than y, either y will have to be here, y can be here, or y can be anywhere on the number line on the left side. Remember that. Okay. So can I take, let's say, x equal to 1, or rather, let's say x equal to 2. Can I take y is equal to minus 3? I can, right? Because I'm not violating this condition. Is y square more than x square? What is the answer? Is 9 more than 4? Yes. On the other hand, what will I do? I'll take x as 2. I'll keep x as 2, but I'll take y as, let's say, half. Okay, so I'll take y in this region of 0 to 1. Is y square more than x square? Is 1 by 4 more than 4? The answer is a no. Okay. Clearly, the first statement alone is insufficient because we don't have any information about y. So the first statement alone is okay. All right. So I think we were on this question on inequalities. I'll just run through what I did. I don't know where I went off track because I was not looking at the screen. Okay, I hope you're able to see now I hope all of you are able to see my screen. So statement 1, we have taken a couple of values. We have got a yes and a no. We have been able to disprove statement 1. Statement 2, we know that y is positive. We also know x is more than y, which means we don't have to consider the left side of the number line, right? So therefore, we only pick values from the 0 to 1 interval. I picked y as 1 by 3, x is 1 by 2. I picked a couple of values from the 1 to infinity interval. I picked y as 3 and x as 4. In both the cases, I got a no. You could probably pick y as 1 by 3 and x as 1 by 4 and ask yourself, is 1 by 3 whole square more than 4 square? Your answer will be a no, which means you've tested all the 3 different cases. And in all cases, you've got a no. So the second statement alone is sufficient to get a no. And that's probably why a lot of you picked B on this, which is absolutely right. Okay. Any questions? Because there was a disruption in the internet, please let me know in the chat box. Meanwhile, let me create a poll because my polls have vanished before we start with the next question. Yes, guys, go ahead. Utilize the time to ask me any questions that you may have before we move on to the next question. Okay. What this disruption has done is it's kind of upset my apple cart in terms of time. We are already at 8:40, because of which I probably will have to skip a question, right? I'll skip question number 6. I'll probably give this out as homework for all of you to try. Okay. Hopefully by now you've realized that the number line method that I explained is a very quick and effective way of plugging in values when it comes to a topic like inequalities, absolute values, quadratic inequalities, sometimes equations, exponents. Okay. This is something we do in our course also. So again, as I said, we practice what we preach. You can see this number line approach is a very prominent appearance in topics on algebra. Okay, because we believe that it's a very powerful tool. With that, I will quickly move on to the last model, how to plug in numbers without doing random number plugging, how to analyze the stem and use the analysis to plug in the right kind of numbers. Okay, that's the final tip that we want to give you. And for that, I have a worked example here, okay, which all of you can solve with me. And there is no poll here. You can solve it along with me. Let's solve it together and see how we can solve this in under 2 minutes. Okay. In a certain town, 20% of car owners. So I see that a percentage is coming up. So I've already made up my mind to think of 100. 20% of car owners receive parking tickets for overnight parking. Great. 20% of the car owners who parked overnight did not receive parking tickets because of a technical issue. So you see another 20%. So my thought process about 100 has become stronger now. I strongly believe that I should take 100. What percent of the car owners in the town did not do overnight parking? So Harsimran, if you are still there, I think this answers your question about whether number plugging works in questions on set theory and Venn diagrams. Okay, because this is definitely a question on set theory. Why? Because you understand that if you are a car owner, you either did overnight parking or you didn't. There is no middle path. You can't say I did and didn't both. Okay. So both of these are mutually exclusive. Similarly, you can receive a ticket. You received a parking ticket or you didn't. There is no middle path. You can't be in both the places. Again, these two are mutually exclusive. Okay, so this is the total. So this is clearly a question on Venn diagrams on a 2x2 grid. So what do we do now? We draw the grid now. Which means I'll have to take the total as 100. But the risk of taking the total as 100 is that I see another 20% coming here about which I don't have any clue. So what do I do in such cases? I don't take 100, I don't take X, I take a combination of both. Okay. Why do I take the 100? I take the 100 to take care of the percentage values. Okay. Why do I take the X? I take the X because I'm uncertain about certain things. I don't know what value will come anywhere in the grid. Okay. So 100x car owners are there in a certain town. Let us say 100x car owners are there. 20% of them receive a parking ticket for overnight parking, which means they did overnight parking. They received a parking ticket. That is 20%. So this is 20x. So can I write this is 80x? No, I can't. Okay. I just know that this is 20x. 20% of the car owners who parked overnight, which means this total. These are the total number of people who did overnight parking. That is the reason why I said I was uncertain about something. Now, do I know this number? I don't know this number. Okay, so what should I do now? Should I take this as 100? Maybe, but I'll follow the same approach. I'll take this as 100y. Okay. 20% of the car owners who parked overnight did not receive parking tickets because of a technical issue. So I know this is 20y. If this is 20y, I know this is 80y. Okay. So by taking a variable, in fact, by taking a couple of variables, I was actually able to find a relationship between x and y. So I now know 20x equal to 80y. So I know x is equal to 4y. So what will this do? This will convert my table in terms of y. If x is equal to 4y, my total will become 400y. Okay. So out of 400y owners, 100y did overnight parking. So how many people did not do overnight parking? Obviously 300y. What is the question? What percent of the car owners in the town? So what percent of 400y did not do overnight parking? Okay. So out of 400y, how many did not do overnight parking? 300y did not do overnight parking. So that's clearly 3 by 4. That is 75%. So sometimes maybe introducing a variable along with 100 is a good idea if you are unsure of the actual number, if the values are given only in terms of percentages. It'll actually make your life simple. Instead of just taking 100 or instead of just taking x, take a combination of both and your life will become simple. If any of you have a question on this, please let me know. Were you able to understand any doubts? Anupam, I took the second variable y because I don't know. Do we know how many people did overnight parking in total in the town? Anupam. No, that is not correct. That is not correct, Anupam. You are reading the question wrong. I will repeat my question. Do you know how many people in total did overnight parking in the town? So the answer is a no. Okay. But you still understand that you have to apply a percentage on it. Because the question is telling 20% of the car owners who parked overnight, which means 20% of this number did not receive a parking ticket. So if you want to find out this value, you still want a number here. Okay. On which you have to apply a percentage. So you either take 100 here, which I'm okay. I'm okay in you taking 100. Or because we are talking of taking variables and 100 together, okay, I just took 100y. Ishita Agarwal, 80% did not receive a ticket. We don't know anything about the number of people who did not park overnight. I don't think that is correct, Ishita, because out of 400y people, if 100y have parked overnight, how many have not parked overnight? They are the complement, no? That's clearly here, no? If you have out of 400 people, if you have 100 people who parked overnight, then obviously the remaining 300 should not have parked overnight, no? Because these are mutually exclusive data. You either park overnight or don't. You can't say I did both. Okay. I didn't get your question. What do you mean I meant from the question itself? Okay, let's clear some information from this screen and let's see if you have a doubt. Let's go one statement at a time. So, if you did overnight parking, you are going to either receive a ticket or you're not going to receive a ticket. Is that clear? Ah, okay, okay, okay. I thought you had a question there. Okay, no problem. Okay, so that essentially is what I wanted to say, that you have to analyze the information given in the question, maybe create a table like this with your with your analysis before starting to take values. Sometimes random number picking doesn't work. Okay, so in cases like this where there's a lot of information given in the question, don't resort to random number plugging. Analyze a little and plug numbers in the second half of the solution. So, for example, this is the last question I had for you today, question number 7, for which I'll run a poll. This is the last poll. What is happening? Okay. Yes, I think all of you are able to see the poll now. Go ahead, I'll give you 3 minutes. Okay, that's time, people. Okay, the last 10 seconds before I close the poll. Okay, that's an interesting poll to look at. Time up. End of poll. 33% alpha. Okay, that's a little bit of a surprise. 16% Charlie, 41% Echo. Okay, guys, the only question I have for people who marked alpha is there something really important that you missed out? I think you're probably trying to figure out now, what did I miss out? N is not divisible by 5. So if you say the remainder is 0 when n is divided by 5, don't you think you're invalidating this information? And you're saying that n is divisible by 5. Think about it. Okay. So what is the pre-analysis that you have to do here? You can't just start plugging in numbers for x because you know x is a positive integer, right? You have to break down the expression given and do some analysis, or at least break it down to an extent where you can simplify it or plug in numbers in a simple manner. So you know x square minus 3x is common. I think the square is outside. So if you take x square minus 3x common from both the terms, here you'll be left with x square minus 3x, okay, plus 2. Clearly, this can be simplified as x times x minus 3. This is a quadratic expression. You can write this as x minus 1 times x minus 2. So our pre-analysis tells us that n is the product of 4 numbers, 4 integers, x minus 3 into x minus 2 into x minus 1 into x. Okay. Now we know that x is a positive integer, which means I know x can be 1, 2, 3, and so on. These are the values I have to plug in. I know n is not divisible by 5. So whenever I plug in x, I should ensure that the number that I get is not a multiple of 5. And therefore, I feel the answer option A is a bad answer, a very bad answer. Because if you say the remainder is 0, you're automatically telling n is fully divisible by 5, which is not the case. Okay. So n is equal to x minus 3 into x minus 2 into x minus 1 into x. Okay. You will realize that if you plug in x equal to 1, this entire value becomes 0 because 1 minus 1 is 0. If you plug in x equal to 2, the same thing happens. If you plug in x equal to 3, the same thing happens. Remember, 0 is divisible by all numbers. Okay, 0 is divisible by all numbers. So is it divisible by 5? Yes. So can we take these values of n? We can't. So what is the first value I can take for n? The first value comes up when x equal to 4. If x equal to 4, the value of n will be 4, 3, 2, and 1, which is 24. 24 is definitely not divisible by 5. What is the remainder when 24 is divided by 5? Clearly 4. Do I stop here? Some of you may say, okay, how do I know that no other option will fit the bill? You can try another sequence of values, another cycle of values. You'll see that x equal to 5 will behave exactly like x equal to 1. Okay. N is equal to 5, 4, 3, 2. Is this permissible? No. Why? Because n is automatically a multiple of 5. There's a 5 here. Can I take x equal to 6? No, because this will become a multiple of 5. Can I take n equal to x equal to 7? No. X equal to 8? No. So I can't take x equal to 7. I can't take x equal to 8. The next value I can take is x equal to 9. If I take x equal to 9, n will be 9 times 8 times 7 times 6. Okay. You divide this by 5. Remainder. Remainder of 6 by 5 is 1, 7 by 5 is 2, 8 by 5 is 3, 9 by 5 is 4. 4 3s are 12, 12 2s are 24. You got the same answer. So you can mark the answer as E. The remainder is 4. Okay. So the correct answer here is E for echo. I think 41% of you got that answer right. With this, I hope that despite the disruptions and the small error that was there in one of the examples, I hope that a lot of you have a lot to take back from today's session in terms of learning how to pick numbers while solving GMAT Quant questions. Therefore, I now urge all of you to ask me any questions that you may have, general, related to the topic, anything is fine. You can either put it in the chat box or the Q&A box. For any of you who want to reach out to us, these are a couple of channels. Either write to support@gmatwiz.com or reach out to us on WhatsApp on this number that you see on your screen. Yes, any questions, please feel free to shoot them at me and I'll be happy to answer. Thank you, Pushpa. Thank you very much for being participative. Thank you, Ranjan. Any of you are signing off at this stage from the session? Thank you very much for participating in this webinar, for having been patient for almost 2 hours, and I wish you a pleasant evening. Yes, the others who have questions, please go ahead, post it in the chat box. Welcome, people. Harsimran, Julia, A, Ashish, thank you very much. Ranjan, I think the next session will be according to the calendar that has been published on our website, which will be, I think, next Saturday. Let me just tell the topic to you. I don't have it at the tip of my tongue. 1 minute. Ashish, how much time we need in total for preparation? See, that's a very generic question for me to answer. As you know, I do not have a single answer for that. It depends on a lot of parameters. Depends on where you're starting from. Okay, in terms of a diagnostic test score, are you starting from a 500? You're starting from a 600. What is your target score? Do you want a 720 or a 760 or a 750? How many hours of preparation you need to put in per day? When are you taking the GMAT? Right? What preparation have you done till now? So it depends on a lot of parameters, right, Ashish? So I can't give a single answer to that. Probably a good ballpark figure to have would be maybe about 3 to 4 months. If you're starting off with your preparation now, taking the GMAT sometime in June, early June will be a good idea, because that means even if your first attempt doesn't go as planned, you have like a full month or a month and a half to just take it again and improve your scores. Okay, so I hope that answers your question. Okay, Ranjan, I think the next session will be on critical reasoning. That is the 5th of March. It will be taken by Sunita. All right, this will be on critical reasoning, techniques related to pre-thinking. Sanket, thank you very much. I hope I've answered your question as well in answering Ashish's question. Okay, so around 3 to 4 months is a realistic timeline to set for yourself. You're welcome, Anupam. Thank you for participating as well. Ranjan, there is no restriction on what there's no restriction in terms of your academic qualification. Anyone who has a graduate's degree, I think, can take the GMAT. In fact, people take it even before they complete graduations. It's completely doable. You're welcome, Ranjan. Sanket, you're welcome too. My pleasure. Sorry. Okay, people, any other questions that you'd like me to answer? If not, I think it's time for all of us to sign off and enjoy whatever is left of the Sunday or the Sunday evening. Alrighty, I think there are no other questions. For all of you who are still here, thank you very much for being for participating in this webinar and being patient and holding on till now. I'll probably see you on another quant webinar in a couple of weeks' time. Till then, take care and keep preparing well for the GMAT. Do register for the free trial on the website mentioned. If you have any other questions, reach out to us on the channels that are shown on the screen. Thank you, people.